Welcome to solverfy.
This problem says a random sample of 46 adult coyotes in a region of northern Minnesota showed the average age to be a sample mean of 2.05 years with a sample standard deviation of 0.82 years. However, it is thought that the overall population mean of coyotes is 1.75 years. Does the sample data indicate that coyotes in this region of northern Minnesota tend to live longer than the average 1.75 years using a level of significance of 0.01? And first for A, we're asked to state the null and alternative hypothesis, and here our null hypothesis would be that the mean is equal to the 1.75, and we want to see if the coyotes in this region last longer or live longer, so that means our alternate hypothesis would be that the mean is greater than 1.75. And to find our t-value, or our test statistic, which would be t here since we have the sample standard deviation, and the p-value for c, we are going to run a t-test in our calculator. And for the t-test, we have to list several values, starting with the null mean, which we have as 1.75. Next, we list the sample mean, then the sample standard deviation, which was given as 2.05, as well as 0.82. Next, we list the sample size, which was 46. And the last thing we list is the alternate hypothesis. And in our case, the alternate hypothesis is that the mean is greater than the null mean. And when we evaluate, we will get several pieces of information, including the test statistic, and t rounded to 3 decimal places comes out to 2.481. And our p-value rounded to 3 decimal places as well comes out to 0.008. And we were given a level of significance of 0.01. So to help us answer our question for D, we can look at our p-value compared to the level of significance, and our p-value of 0.008 is less than the level of significance of 0.01. And when our p-value is less than the level of significance, that means that we have evidence to reject the null hypothesis. So in this case, we would be able to support the claim that the coyotes in this region do live longer than the expected 1.75.